Okay, now that we know what the absolute value parent function looks like, let's move them around a bit. The first thing we're going to do is translate. Translate is just shifting our function. It's a lot of times it's referred to as shifting. We're just basically moving it left or right or up or down. We're not changing the general shape. We're just moving them around the page. Okay, so first thing we're going to do is a vertical translation. I love moving vertically. Again, vertically is up and down. If you didn't know, vertical is up and down. I always like to refer it to a lot of times in like basketball or sports, like, yeah, he's got a really high vertical. That's he can jump really high. So vertical is up or down. To move a graph up or down, I take my function and we add on to the end. So we're going to say we're going to add C. So what this is going to do is this is going to move it up C units. So adding C is going to move it up C units. So subtracting C is going to move it down C units. So I don't even have to graph or like plug in points or use my calculator to know what the graph, if I have my parent, so I'm going to do my parent here in red. So the parent is just that straight. We talked about the parent just here a minute ago. My parent, here my f of x, my parent is the absolute value of x. So adding, okay, so here adding C units. So if I wanted to graph the absolute, let's say I'm going to have now a new function, let's call him g of x, and he's going to be the absolute value of x plus 3. That's going to move take this red function and move it up 3. So I just take this red guy, move him up 1, 2, 3. All the other points are the same. And this is going to be the absolute value of x plus 3. Move it up 3. Okay. So if I want to move it down, then I subtract, like subtract 5 or subtract 8. That's going to go ahead and move it down. So here, if I take this graph and move it down 1, 2, 3, 4, let's go down 5. I know what the equation of this graph is going to be. It's going to be the absolute value of x minus 5 because I moved it down 5. Okay. So vertical translations are awesome. They work exactly how you think it would. Horizontal, on the other hand. Horizontal is left and right. Much like the horizon in the distance goes left to right. Horizontal, I'm going to put a star here, works backwards than what you think it would. You would think if I want to move it right, I'm going to add. But if I add, it's going to move it up. Okay. How a horizontal works is you actually add inside the function. So it happens inside. What we mean by inside the function, we put it in on the input. So I would graph f of x plus c. That plus c, if you notice the difference in my parentheses, over here, it's f of x, my function, and then I just add c on the end. Here, my plus c is inside that parenthesis. So if my parent function is absolute value, it's going to be the absolute value of x plus c. Notice here this plus c is inside the absolute value. Whereas over here, my plus 3 was outside. My absolute value is still just on the x. Here, my plus c is inside on the x. So we would think if I put it inside there, it would move it. Plus c is going to move it to the right. Horizontal works backwards. If I add c inside of there, it's actually going to move it left. Okay, we normally know a standard number line, right is positive, right? Left is usually negative. But again, horizontal works backwards. So adding a c inside of there is actually going to move it to the left, c units. Whereas f of x minus c, absolute value of x minus c, is actually going to move it to the right. Okay, so if we come in and graph our parent, oh, that's kind of crooked. Ignore that one. We're just going to zoom on past it. So again, so here's my parent, f of x equals absolute value of x. If I have the absolute value of x minus 5, that's actually going to move it to the right. That negative is actually going to move it to the right. So it's going to take this red graph and move it right. 1, 2, 3, 4, 5 over here at 5. But the graph's going to look the exact same. It's just now to the right. Okay. If I go left, 1, 2, 3, 4, 5, 6, left 7. I know the equation of this is going to be the absolute value of x plus 7, because that adding 7 moved it to the left. Because again, horizontal translations work backwards. And really, horizontal everything works backwards as far as transformations go. So we're not even going to talk about horizontal stretches or shrinks yet. We're going to get to stretches or shrinks next. But this is a translation. This is what we refer to as a rigid transformation. It's rigid because it doesn't change shape. Okay. It's just taking this graph and just moving it around, moving it left, right. And you can do both. You can move it left and up, like all at the same time. Like up would be on the outside, and left or right would be on the inside. Okay. All right. So now we're going to get into our stretches or shrinks. This textbook refers to the shrink as a compression. So instead of shrink, it uses the word compression, but really it's the same idea of shrinking. Basically, it's just kind of making it smaller or pushing it down. So again, a stretch is going to stretch it out. We're going to be dealing with strictly what we call vertical stretches or shrinks, where it's stretching or shrinking it up and down. Oh, that isn't how you spell down. Okay, so it's stretching it up or down. It's like grabbing something from the top, like grabbing a person from the head if they were a gummy person, and pulling their head up. It's going to make them taller and skinnier. So to stretch or shrink, we take our function and we multiply out front times something. So we're going to multiply, we use the letter A times f of x, which is if our parent is the absolute value, it'd be A times the absolute value of f. Now, if A is bigger than 1, it's going to stretch. For example, if it's 5 or 6 or 2 or 3, okay. If your A is less than 1 but bigger than 0, meaning, okay, a fraction, it's going to shrink or compress. Okay. So the best way to demonstrate this is to just go ahead and do an example. So again, let's go ahead and let's graph our parent function over here. Okay. Sorry, this graph is so tiny. We're going to go ahead and graph our parent. It's just absolute value of x, right? It looks like this guy just hits those diagonals. So there's our parent. Okay. Now, if I multiply out front, if I have 3 times the absolute value. Oh, wait, let's not use 3. Boop, 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 boop. Let's do 2. That's going to be easier to graph. 2 times the absolute value of x. This number is greater than 1, so it's going to be a stretch. It's going to take each of these points. Let's say this point here, 1, 1. And it's going to make it now twice as far up and down. So instead of being up 1, it's now going to be up 2. Now this one, the point 2, 2, is now going to be twice as far. So it's now going to be up here at 4, twice as far. Here it's up at 3, it's going to be twice as far, so it's going to be up here at 6. So if we put those points in, instead of being up 1, it's going to be up 2. Here this one is up 2, it's going to be twice as far, so it's going to be up here at 4. This one is 3, it's going to be twice as far, so it's going to be up here at 6. So, and then 0, twice as far as 0 is still 0. So it really gives me this taller, skinnier graph. So there's multiplying by 2. Whereas if I multiply by 1/2, here, let's switch color. By 1/2, let's color in green. It's going to make it half as far. So now instead of this point being up 1, it's half as far. It's going to be up a half. This point, instead of being up 2, it's going to be half as far. Instead of being up 4, it's going to be half as far. So it shrinks that graph down. So it's really shrinking, taking this red graph and shrinking it down. Whereas this blue one, it's stretching it up. Okay. So that's our stretch and shrink. This is a non-rigid transformation. The shape of the graph is changed, right? It shrinks it down, it makes it skinnier or fatter, wider or narrower, depending on how you want to describe it. Okay, the last thing we want to talk about is a reflection. So we're going to be reflecting over the x-axis. So basically, it's going to take my parent function. So again, you notice we start by graphing the parent a whole lot. That's just really common and really under practice. That should be pretty commonplace. Graph the parent first because the parent is pretty straightforward to graph. It's just that nice V. 1, 1, negative 1, negative 1. Okay, so what we're going to be doing is we're going to be reflecting that guy or flipping it over and reflecting it over that x-axis. So it's going to be flipping it down like that. So it took, instead of being the point up 1, it's now down 1. Now, since I'm going down 1 instead of up 1, that's a negative. So that's going to take a negative times f of x. So it's going to be a negative out in front of my absolute value. Because if you notice up here, we talked about this number up front being either greater than 1, right here, or in between 0 and 1. We didn't talk about anything happening less than 1. Because if it's, less than 0. Because if it's less than 0, it's a reflection. So here we're reflecting over the x-axis. So those are the 3 types of, these are all called transformations. So these are all called transformations. They're all different ways of transforming or moving our parent graph.